In this video, we're going to be doing some review problems to help you for your Chapter 1 test. So one of the things I'm going to check is that you know how to classify different types of numbers. So here I have my natural numbers, 1, 2, 3, 4. Whole numbers also include 0. Integers are your whole numbers but including negatives. And then rationals have your fractions, your decimals that can terminate or repeat. Irrational numbers are the ones that if you change them to decimals, they're going to keep going forever and ever without terminating or repeating. And remember, all numbers are real numbers. So here, if I wanted to classify negative 1/4, since it's a fraction, it's rational. And remember, all numbers are also real. So it's rational and real. If I wanted to classify negative 6, it's a whole number, but because it's negative, it's an integer. So it's an integer, and integers are also rational and real. The reason it's rational is you can write it as a fraction. You could put it negative 6 over an imaginary 1. 0 is a whole number, and if it's a whole number, it's also an integer, rational, and real. So if you look at your chart, whole numbers, 0 is there, but it's also included in the integers. It's also rational because you can write it like 0.0 or 0 over 1, and all numbers are real. Evaluate just means to plug in for your numbers and simplify. So I'm going to plug in negative 2 for A, and I'm going to plug in 6 for B, and then I'm going to start to work this out. So 4 times negative 2 is negative 8. And then negative 8 minus 6 is negative 14. Once you get your absolute value simplified, you can actually take the absolute value. The absolute value of negative 14 is positive 14. But because this question had a negative separate from that, even though the absolute value became positive, that negative is still in the final answer. So our answer here is negative 14. Here to simplify, we're going to distribute. To get rid of parentheses, then we'll combine like terms. So first, if I do 1/3 times 6x, 6 over 3 is 2, so that's a 2x. 1/3 times 3 is going to be 1, because 3 divided by 3 is 1. If it's positive, you put a plus. Negative 4, remember you're treating that like a negative 4, times 3x is negative 12x. And then negative 4 times negative 2 is a positive 8, so I'm going to put plus 8. From here, we want to combine like terms. So I can combine 2x with minus 12x. And I can combine 1 with 8. So plus 1 plus 8. 2x minus 12x is negative 10x. And 1 plus 8 is a positive 9. So here my answer would be negative 10x plus 9. Remember, there's different ways to write your answer. So you could also switch the order and write it as 9 minus 10x using your commutative property. On this next problem, we're going to solve a simple equation for x. So your first step would be to distribute. 3 times 5x is 15x, and then 3 times negative 1 is negative 3. This equation, we have variables on both sides. I usually undo the smaller one. So I'm going to undo 3x by doing minus 3x to both sides. On the right side, plus 3 just means it's a positive 3. From here, I'm going to continue to solve. So I need to move stuff away from x. 12 is stuck to x, so I'm going to get rid of my 3 first by doing the opposite. So I get 6, and then the last step, they're multiplying 12, so you would divide by 12. Here I'm going to simplify. So 6 over 12, don't say it's 2, that would be 12 over 6. Here you would simplify by dividing by 2, and then your fraction actually becomes, sorry, I'm not going to divide by 2. I can divide both of those by 6. So if I divide by 6, my fraction becomes 1/2. This next problem is an absolute value equation. Remember, Your first goal is to isolate your absolute value. So I'm not combining like terms, I'm moving stuff away from it. So I get rid of plus 7 by doing minus 7 to both sides. Remember, once your absolute value is by itself, you need to check. So on this step, I need to check if it equals a positive or a negative. Here it equals a negative. Remember, absolute value can't be negative. So if it equals a negative, you stop. Your answer is going to have no solution. And you can use an empty set to show that your answer is no solution. Here we have another absolute value problem. So my first step is to get the absolute value by itself, or to isolate it. They're multiplying 5. Don't try to distribute. Remember, these are like boundary lines. You can't cross them. So the opposite of multiplying 5 would be to divide 5. So we're moving stuff away from our absolute value to isolate it or get it by itself. So I get 4 equals absolute value of 2x minus 12. Now that my absolute value is by itself, I do my check. I want to see if it equals a positive or a negative. Well, here it equals a positive 4. So this one is going to have solutions. Remember, from this step, absolute value can have up to 2 answers, because the absolute value of 4 is 4, and the absolute value of negative 4 is also 4. So I'm going to set up 2 problems. One of them will have 4. The other one will have negative 4. And now I can solve these to get my 2 solutions. So here 2 stuck to x, so I'm going to add 12. And now I can divide by 2. So my first solution is an 8. My second one, I'm going to do the same steps. I'm going to add 12. Negative 4 plus 12 is 8. And then if I divide by 2, I get 4. So my 2 solutions are 8 and 4. It's more proper to go from least to greatest, so I'm going to put 4, 8. But if you put 8, 4, that's fine. You're just showing these are my 2 answers. We also covered solving regular inequalities. So here, my first step is to distribute the negative 2. Negative 2 times r is negative 2r. And negative 2 times negative 11 is positive 22. From there, I'm going to combine like terms. So 22 and 12 will become 34. Now I'm ready to start solving or moving stuff away from my r. Since these are stuck, I'm going to get rid of the 34 first. 6 minus 34 is negative 28. And now I can divide by negative 2. Remember, when you have inequalities, there's a rule. Anytime you divide or multiply by a negative number, your symbol is going to flip. So since I divided by a negative 2, my symbol is going to change to less than or equal to. And then negative 28 divided by negative 2 is 14. So our final answer became a less than or equal to, because we divided by a negative. Always check that step. Here we have another inequality problem, so I'm going to solve for y, but here our final answer is going to be our graph. So 2 and y are stuck. I'm going to get rid of my 5 first. So I get 14 is greater than positive 2y. Now I can divide by 2. We're dividing by a positive 2, so for now my symbol stays the same. I get 7 is greater than y. Remember though, before you graph, before you box your final answer, your variable needs to be in front. The proper format is to have your variable, then your symbol, then your number. So we want to have the y first. So when that happens, you're going to have to reverse everything. So I'm going to fix my format. And when I do that, this actually flips and becomes y is less than 7. So here our final answer is y is less than 7. Now that I have it in the proper format, I can graph my solution. So I'm going to draw a line with a 7. my circle is going to be on 7. Since this one does not have the equal to, it's unshaded. And less than looks like an arrow to the left because you want to shade the numbers that are lower than 7. So again, do not graph until it's in the right format. If you didn't flip this, then you might have graphed it like this, thinking, oh, it's greater than 7, and it would have been incorrect. So make sure that before you graph, you fix the format, because if not, you're going to want to do like the black number line I have here, which is wrong. The last topics that we covered were compound inequalities and absolute value inequalities. So here I have an absolute value inequality. Since my absolute value is already by itself, I look at my symbol. This is a less than symbol. Remember, if it's less than, it's an and problem. So I'm going to split this into 4x minus 6 is less than or equal to 10, and 4x minus 6 is greater than or equal to negative 10. Remember to flip the symbol and change the sign. And now we can solve. So 4x is less than or equal to 16. X is less than or equal to 4. My next one, I'm going to do the same steps. So 4x is greater than or equal to negative 4. Divided by 4, I get x is greater than or equal to negative 1. Always graph these to check if you have a special case. So I'm going to graph. If it's an and problem, you want to graph them separate to see where they would intersect. So less than or equal to 4 would be shaded to the left. Greater than or equal to negative 1 would be shaded to the right. So these are going to intersect from negative 1 to 4. And remember, when it's an and problem, your final answer is going to be in the format number is less than x is less than a number, because you're going from least to greatest. So here, negative 1 is less than x is less than 4. And since my circles are shaded, I'm going to put my equal to symbols. Our last problem here is also an absolute value inequality, but this time we need to get the absolute value by itself first. So since they're multiplying 3, I would divide by 3. Now that it's by itself, I'm going to decide if this is an and or an or. Well, remember, if you look at your symbol, greater sounds like great or. So this is an or problem. So I have n plus 6 is greater than 3, or n plus 6 is less than negative 3. And we can solve these for n. Now that I have my solutions, again, you want to graph to check if you get a special case. So I'm going to draw my number line. When you're doing an or, you graph them on the same line because it doesn't matter where they intersect. It can be either or. So n is greater than negative 3 would be unshaded to the right. And n is less than negative 9 would be unshaded to the left. When you write your final answer for or, you leave your answer separate. You just put the word or in between. So this side shows n is less than negative 9. Then I write or. N is greater than negative 3. Something that we didn't cover on the Kahoot, but that might come out, are your compound inequalities, which is very much like what we just covered. You just need to know how to separate them when it's an and problem. So if I were to give you something like this, when you start it, this one's an and because they didn't specify if it was or not. You're going to split it into two problems, 6 less than or equal to 2x minus 1, and 2x minus 1 is less than or equal to 10. And you could solve from there. So from there, the steps are the same as what we were just doing with the absolute value problems. Another thing that we covered is make sure to do your number lines when you get your answers. So let's say we get an answer, x is less than 10 and x is greater than 15. When you do your number line, if it's an and, you want to graph them separately and see where they intersect. So less than 10 would look like this. Greater than 15 would look like this. This is an and, so you want to check where they intersect. If they don't intersect, then you'll end up with an empty number line. And an empty number line means you have no solution. So again, very important that you graph your final answers. Another possible answer you could get is like x is less than 1 or x is greater than negative 2. When you have your OR problems, you graph them directly on your number line. So x is less than 1 would be shaded to the left, and x is greater than negative 2 would be shaded to the right. So this one, everything ended up shaded. Remember, if your whole line ends up shaded, then your answer is actually all real numbers. So these are the special cases. Remember to always graph, because if you don't graph, you might not notice that a special case came out. Again, this video is just to help you study for your test. In case you felt you need extra practice, you can also go look at any of your assignments that you turned in for chapter 1. If you want to play the Kahoot again to practice on your own, you can.